Example 3, we're going to look at the shape of the histogram. A histogram is useful to describe the shape of the data distribution. It's important to think about the shape of the data distribution because depending on the shape, there are different ways to describe important features of the distribution, such as center and variability. A group of students wanted to find out how long a certain brand of AA batteries lasted. The histogram below shows the data distribution for how long in hours that some AA batteries lasted. Looking at the shape of the histogram, notice how the data mound around the center of approximately 105 hours. We would describe this shape as a mound shape or symmetric. If we were to draw a line down the center, notice how each side of the histogram is approximately the same or a mirror image of the other. This means the histogram is approximately symmetrical. So again, let's look at the histogram. Notice that the data mounds around the center of about 105. Now we don't know that it's exactly 105 because in a histogram the data is given in intervals. But we can see that it's sort of in the center right here. Matter of fact, if we connect the tops of the bars, we can see that mound shape. Oops. And if you look at each side, they're about the same. Now I know they're not exactly the same, but they're about the same on each side. So we would call that approximately symmetrical. If they were exactly the same on each side of that center, we would say they are symmetrical. They are exactly symmetrical or perfectly symmetrical. Another group of students wanted to investigate the maximum drop length for roller coasters. The histogram below shows the maximum drop in feet of a selected group of roller coasters. This histogram has a skewed shape. Most of the data are in intervals from 50 feet to 170 feet, but there is one value that falls the interval from 290 feet to 330, and one value that falls in the interval from 410 feet to 550 feet. These two values are unusual or not typical when compared to the rest of the data because they are much greater than most of the data. If we look at this data here, notice how it sort of slides, if I can draw it correctly, there we go, sort of slides off and tails off to the right here. That's what we call skewed. We would say that this data distribution is skewed or tailed to the right. These pieces of unusual information don't match up with the rest of them. Most of the data is mound up or between 50 and 130 or 50 and 170, but then we have these unusual ones that cause us to skew off to the right, tail off to the right. Now what I would like you guys to do is to turn to exercises 5 through 9. I would like to answer those questions, and then I would like you to check yourselves given the answer key.